So question number 5 here. So how do we, it says multiply the following and express your answer in scientific notation. So I've got 1.7 times 10 to the minus 21 times 6.9 times 10 to the minus 47. And I want to basically multiply in scientific notation and write the answer. So how do I do that? How do I multiply in scientific notation and write the answer? Well, I think what you would guess is you just take this number and you multiply by that number, and that's right, because we are multiplying. So let's multiply the numbers in the front. So just grab your calculator, multiply 1.7 times 6.9 or whatever numbers you have in the front. I'm getting 11.73. Okay, and now what are we going to do with these powers? What are we going to do with 10 to the minus 21 times 10 to the minus 47?
Would you change those to like the decimals?
Yeah, let's think about it. It's a good question. Let's think about for a second over here on the side. You know, what do you do? What do you do? Here's a great teaching moment, especially for you who are becoming teachers. I really want to encourage you to teach younger folks that math is about truth and patterns. So if you're doing something in a math course like this and you're like, I don't know, I don't remember, that's crazy, what do I do? I know there's probably some rule, I can't remember it. Well, here's what you should do. Go over on the side and make a simple example. Observe the pattern and do the same thing on the harder case. What do I mean? Well, just think of 10 squared times 10 cubed, right? Just make them simple numbers instead of negative 21 and negative 47. Yes, we're just going to add up. So what Danielle says is we're going to just add them up, and that's right. So let's see it. Let's see what is 10 squared? Well, we all know that means 10 times 10, right? I'm not doing something you don't know. You know that. And then this got this times in the middle. And what is 10 to the third power? Well, again, you already know it, right? It means 10, 10, 10. Right? A 2 power means 2 tens, a 3 power means 3 tens. So what do we have all together there? 5 tens, don't we? So look at that for a second. It'll take you a second. What are we really supposed to do with those powers? Clearly, the shortcut is just to add the powers, isn't it? See how you can quickly recreate the rules for yourself if you forget rules? That's a great thing. I have a terrible memory. My family kids me because I don't remember anything, but I made it through a couple of math degrees because math is not about memorizing all these rules. It's about following the pattern. See how you don't even have to remember the rule. If you will just create a little example like that for yourself, you can just go, oh yeah, there it is. It's just like that. That's what math science people do. That's what you want to train. You're going to have little future engineers and scientists sitting in your classrooms. And so you want to start training them from an early age that math is about logic and patterns, not memorizing a bunch of rules. How boring and dumb that would be, and hard too, to have this perfect memory for all these millions of dumb little rules everywhere. No, math is patterns and logic. So just look at what's true, go, oh yeah, you just add the powers. I know that. So that's what I'm going to do here. Same exact plan. So negative 21 and negative 47. So it's going to be negative 21 plus negative 47. You just add the two negatives, huh? So what is that? Negative, use your calculator, 68. Negative 68. Oops, kind of ugly. So negative 68. All right, good. So we got our answer. Let's bring it down. So it's 11.73 times 10 to the minus 68. Are we good there? So now, so what did we do? What did we do on this problem? We took the numbers in the front and we multiplied them on our calculator. And then we took the powers and we added the powers, right? So we multiply, let me write a note somewhere for us. So we multiply the numbers in the front, multiply the numbers in the front, and we add the powers. Add the powers, well, enough said. Add the powers. Multiply the numbers in the front, add the powers, boom, we got it. But actually, hold on, we don't got it. We're almost there, but we're not quite there. This is not the right answer. If you type this in, it'll say wrong. Why? Why isn't that the right answer?
Because you only need one number in front of the decimal.
Yeah, good job. Look what it said up here. Express your answer in appropriate scientific notation. This is not scientific notation. Remember the definition of scientific notation? Write it over here just to remind you. Scientific notation, you must have the decimal after the first digit, right? Scientific notation, number one, decimal after first digit, right? And then of course times 10 to some power. So you've got to have the decimal after the first digit. That's not in the right spot, is it? It's got to be after the first digit, not the second. So that's not scientific notation. So we got to fix it. Okay, well then just put it right there. Just put it where it needs to go, right? Now it's good. Now it's after the first digit instead of after the second. But we can't do that. We can't just move it arbitrarily. Why not? Why can't I just do that? If a child did that on their paper and you told them that's wrong, how would you explain why that's wrong? Would you just say, just do what I say, kid, no more questions? Hopefully not. What would be the reason? Why is that wrong? Right? Why can't I just say, look, you want the decimal after the first digit? All right, I did it. There you go. No. Why not?
Because scientific notation requires that you only have one number in front of the decimal. So with any kind of problem or answer you're given, you need to make sure that there's only one number in front.
But I've got that. I've got only one number in front now.
If you do that, they won't know. They'll just put down the dot or the period. Or the decimal. They put down the decimal without knowing why.
But isn't it correct though?
It's correct, but not the what's it called, the exponent.
The exponent's wrong.
Yeah, why is the exponent wrong?
Because you moved the decimal an additional place. So it has to be, I think 67.
Yeah, good job. Exactly. Yeah, right. Because if you move the decimal there, you've got to change the power. Exactly, guys. You've got it. I'll quit fooling around and get right to the point. Right. You have to take that part. You guys have got it. You've got to take that part and rewrite it. In other words, it's got to become 1.173 times 10 to the positive 1, doesn't it? Because that is the same as that. And then you combine these two. And like Martine said, it's going to be 1.173 times 10 to the minus 67 because we added those powers, right? Let me move it right there. You can see it. Does everybody see that? That's exactly it, right? So you have to take this part and change it so the decimal's after the first digit, but we have to put times 10 to the 1, so it's really the same. Right? We're not changing the number, but just the way it looks. Right? 1.173 times 10 to the 1, that's the same as 11.73, right? That plus 1 tells the decimal to go 1 to the right. So this number is now the same as this number. And then you combine the 10 to the 1 and the 10 to the minus 68, And remember, you add the powers. We've talked about that. You add the powers. So +1 plus -68, that is -67, right? Because when you add a negative, it really subtracts, doesn't it? When you take 1 and add -68, it actually subtracts. And so there is the final and correct answer. So is everybody tracking with that? That's a fairly complex question there. So from the beginning then, let's run over this again. You've got to multiply the numbers in the front on your calculator, add the powers on the tens. You get this, and then you go, okay, but this number's not in scientific notation yet. They want it in scientific notation. So you got to rewrite that as 1.173 times 10 to the 1. That's the same as 11.73. And then you combine the two powers of 10. Again, you add the powers. 1 plus -68 is -67. There we go. A lot of steps to that one.